Let's look at how to assemble this Filament Drybox, a remix of the excellent Ultimate Drybox by Gunpla Mark. There are a number of printed parts made out of various materials. We have a little container for the desiccant made out of clear ABS. We have a TPU part that's the cap that seals the box where the filament comes out. We have ASA parts that are all of the parts that are inside the container that need to be somewhat heat resistant if you're going to use a filament dryer. We have the two top pieces that are out of PLA. They don't need to tolerate heat, so PLA works fine. We need a stainless steel 8mm tube to use as the axle. And we also need some tools. I recommend step drills to drill the holes into the cereal container. I don't think anything else is going to work very well. We need some larger holes, and a large drill wouldn't work. You really need these step drills. We also have some printed parts that are printed out of PLA that are just tools that we use for assembly. We also will need some super glue. Various things have to be glued together. I use two different types of super glue. One claims to be good for plastic, and the other is just a general purpose thick viscosity super glue. So let's get started. First we're going to make the axle that the spool spins on. There's this tool that's printed out of PLA that gives the exact length for this axle without needing to measure. So you just put the stainless steel tube into the tool and then mark with a permanent marker where it needs to be cut. And then I use a tubing cutter that I bought off of Amazon to cut this. It works very well, fairly easy to use. So you thread the cutter on. Line it up with the mark you drew. Crank down on the cutter. I find that I can't spin that thing easily by hand, so I just chuck it in a cordless drill. You don't want to tighten the chuck too much because obviously it's a hollow tube. You could deform it, but it's pretty robust. It's made out of steel. So if you use your drill, it really is very easy and quick to cut the tube. Just keep cranking down as the cut needs to be made deeper, and with a couple of turns it'll come right off. There we have a perfectly sized axle for the filament. Next we need to fasten the two plastic ends into each end of the axle. Often there's a burr that was formed by cutting the tubing. I use a deburring tool to chamfer that inside edge. It makes it a lot easier to get the plastic parts in there. I want to have a fairly tight fit. We're going to glue it, but I think it's good to have a tight fit. So this is the larger part, goes in one end, and just doing a trial fit first, and this knocks off a little of the plastic sometimes just to make it fit better. So once I got it in, take it back out, apply some super glue, and then reinsert it. The other end is a much smaller piece that I always print with a brim, otherwise there's no way it wouldn't come off the build plate prematurely. So the brim removes very easily, at least with my printer. And this one's a little looser. And again, we use super glue and insert that into the other end of the axle. And then we'll set that part aside as it's finished and just allow the super glue to set. The top external PLA pieces are printed with a hinge that allows us to print them and then fold the pieces and glue them with super glue. And this allows you to get a very detailed and clean top and bottom surface. So spread your super glue and then fold it over, and it should just perfectly align itself. There are 3 alignment holes that you can look through to make sure that everything lined up appropriately. I have had 0 problems with that. We assembled the second piece in exactly the same way. Again, super glue, fold it, hold it till the glue sets, and then set it aside. I want to start fastening the magnets to the spool holder, and it's probably best if you put together the spool holder rewinder tool first. It has 6 magnets on it, and the polarity of those magnets on that needs to match up with what you do on the spool, so it's probably best to put that together first so that that sets the polarity you use on the spool holders. I use these N52 neodymium magnets. They're 18 millimeters round, 3 millimeters thick. They're very strong. It turns out it really makes a difference what type of neodymium this magnet material is made of. These are N52 that are as strong as I've ever encountered. You need 3 magnets for the spool holder, and you need to fasten them one at a time and let the glue set between fastening each one, because they're so strong. They'll actually attract the other magnets when you glue them, and if they haven't set, then they'll all move around after the fact and not be where you want. So here I'm fastening the first one again with some super glue and let it set up a bit, and then we'll set it aside and let that glue dry for a bit so that we can put the second magnet on later, and it won't cause the first magnet or the second one to move around. I'm going to work on the cereal box container itself now, and we have, of course, the top and then the body of the container. First, going to remove the lid piece that is not needed for a dry box, so you can recycle that. And I like to flex the tabs on the lid because the ones I get, those are pretty tight and often will not stay snapped if you don't give them a few flexes back and forth. So we want to put the lid on the container. Now we're going to use our jig that we printed out. It's this triangular shaped piece, and we'll use it to mark where we need to drill holes. And we need to be paying attention to the quote front of this container, which is the part of the container with these 3 grooves, vertical grooves on it. So that's the front side of it. And so we place our jig such that the little tabs at the bottom fit onto the tabs that fasten the lid. And you want to push that to the left towards the back so that that frontmost one is in contact with the tab on the container. And this side gets 3 holes. So we mark all 3 holes in the jig. And the other side will only get 2 holes. It will have only the 2 outer holes because it doesn't have a center hole. So there you see our 3 holes on that side. Then we'll flip it over. And now when we put the jig, you want to push it so that the left tab is in contact with the lid's tab. And again, we only want 2 of the holes, so don't mark the center hole, just mark the left and the right holes. And a Sharpie works really well for marking these holes. The last hole we'll mark with a jig uses this jig that is from the original thing we remixed, and it marks the location that we bore a hole for the filament exit, and you just need to mark the center of that. That jig fits right over the front tab of the container. We're going to then drill the holes. This is a 3.4 millimeter drill. That's a good clearance drill for the M3 screws we'll use for most of these holes. So it's used for all of the holes, and it's a pilot hole for when we use the step drill for the larger holes. So the 2 on that side, we'll drill all 3 of these. The center one's going to be drilled out with a step drill, but it's very useful to have a pilot hole for that. So drill those 3. And we'll drill the front hole. Also, this is a pilot because we'll use a step drill to drill this out. Now we'll replace our bit with our smaller step drill. This is a step drill that's between 4 to 12 millimeters is the range it covers. These step drills I bought on Amazon, they work really well. Not very expensive. And as I said, they're really the only way that I know of to get a clean hole in this material. So this hole goes on the front using the pilot hole we drilled previously, and we are drilling this out so it fits this pneumatic Bowden tube style fitting. And so you just drill it out and try to be fairly cautious. It's really easy with a sharp step drill to just accidentally drill it out too much. So try to be as cautious as you can. Definitely need a drill that has a nice slow speed mode. And as soon as it fits, you're done. Now we'll change to our larger step drill bit, which is a 4 to 22 millimeter bit. And we'll use this to drill the hole on the side of the container. And that's to fit a clearance hole for this fitting where the threads are. So we'll use that to make sure we get the correct size. So we go to the side where we have the 3 drill holes, and the center one's the pilot for this. And again, you have to be careful. It's so easy to drill a little too aggressively and get too large a hole. So take it as slow as you can, and as we get close, you can just take the piece that's going to fit through there and see if it is large enough yet, and creep up on that slowly until it clears. This fitting I'm using here is what we glued into the axle. So if you don't have more than one of them printed already, you can just use the axle that you've already glued the pieces into to fit in there. So there we have it, a good clearance hole, and we're done with the step drilling. Take the lid off and clean out those holes. I just use my fingernails to pry the plastic off. We'll work on the lid now. This plug should have been printed in ASA, just fits right in where the rubber stopper is in the lid and should fit in there well. And then we have these brackets that go into the lid, and this is the front bracket, fits around the stopper we just put in. These pieces I print in 2 pieces simply because I find it difficult to print these pieces without warping if you try to print it as one single piece. So instead I split it in half and fit it in individually, and I originally was going to glue them together. It seems like you don't need to glue them. They fit in real well and just stay there. So this is the back piece. It is the one piece that has to be printed with supports for the back place where it clears that hexagonal feature. But it prints really well, at least on my printer, with those supports. It's a simple way to do a support there. And here I'm just putting the desiccant container in. It fits in the rear portion like that. Going to work on fastening the second magnet onto the spool holder now that the first the glue is set. Again, you got to be very vigilant with the polarity of the magnets so they'll match up. Put a little CA glue and fasten the magnet, and make sure you hold the magnet in place long enough that it's not going to move around in the magnetic field that first magnet's putting out. So you probably have to hold it longer than you did the first magnet. so it doesn't slip around. Switching back to the container, we're going to put some of the fittings into it using the holes we drilled previously. So all of these fasten in using M3 socket head screws with M3 nuts. So this fitting goes with the large hole that we bored, and we'll need to put the hex nuts into this fitting. The fit on these hex nuts is pretty tight in my printed version of this. To get them in, I actually use a hammer and this solid steel round bar I have. So I just place the nut into its cavity and then place the round bar on top of it and give it a couple of good raps with the hammer to seat it where it belongs. And you'll need to do this with a total of 4 nuts for these parts, because there's the other piece that goes on the other side that has the same features. This is the second piece that has 2 more nuts that you should put in place. So here are 2 pieces with the nuts fitted, and we'll now place those into the container and screw them in. These fasten with M3 by 6 millimeter socket head screws. So the one with the larger opening goes where we bored the larger hole, and it goes with the flat part against the container, and it's symmetric, so it can go, there's no up or down on it. So we take our socket head screw and screw in both of those. I like to place the axle fitting that goes in the center in the large hole into this part before I tighten things down, because that's actually the feature that matches that hole, and we want to make sure that any slop in this, screwing this in, works to our advantage such that the piece goes into the center of that hole. So I usually put that in and then do the final tightening of the 2 socket head screws. And then we'll fasten the other fitting into the other side. Again, the flat part goes against the side of the container, and 2 more 6 millimeter M3 socket head screws. And this has no specific alignment, so you just tighten them down. For the front of the container, we first need to put the humidity measuring device into the little frame. Should match up with it, just snaps in. And note that that is the proper orientation for it. It sits above the filament exit fitting. So we have that. And we'll go to the front of the container and take our Bowden tube coupler Insert that in the hole we bored earlier, and then we take this printed ASA plastic part that has threads in it and screw that in to the coupler. This part I always print at 0.1 millimeter layer height, and that for me gives very good threads for that. I have these printed parts that fit onto the fitting to allow you to tighten it. Obviously it doesn't need to be super tight, but it allows you to easily adjust it. More importantly, you want to adjust it so that your humidity meter is properly aligned and isn't crooked. So I usually just use that nut and screw it a little bit to just make it line up nice and level. I'm going to fasten the top external pieces now onto the container. First we'll do the front piece, and the pieces have grooves in them that should fit perfectly with the lines on the top of the container. So you wiggle it around and make sure they seat. Once it's seated, take your 3.4 millimeter drill and drill out both the holes in the PLA to enlarge them and the container beneath so that they're lined up. Remove the piece, get rid of any burrs. This is the inside piece that's used to hold the nuts for the screws that fasten the piece. These are much looser than the nuts for the inside pieces for the axle. They're M3 nuts. Sometimes, oddly, even though they're loose, it's hard to get them to lie flat. But using a little stainless steel rod jiggers them around. I use some painter's tape to keep them in since they're not tight. And we take the top piece, and you want to wiggle it around, make sure it's seated properly. Once it's seated, it really shouldn't wiggle at all. And we use an M3 by 8 millimeter screw for this. And place the inside piece on the screw. This piece is more or less symmetrical. Obviously it was printed actually with a orientation, but I don't think it really matters which way it goes. And then you thread the top screw in. I like to wiggle it around before I tighten it down, so just get it to engage and then wiggle it and make sure it's seated still, and then put in the front screw. Again, same size, M3, 8 millimeter, and tighten that down. Once those are engaged, you can remove the painter's tape. And before you really tighten things, again, make sure that top's engaged, tighten it down. It can get pretty tight. And tighten the other one, and that piece is finished. Next, we'll turn our attention to the back piece. Back piece has a slot that's used for this mounting system. Again, it fits with the recessed grooves into the lines on the top of the container. 3.4mm drill through the PLA, through the container. Again, 2 holes. The inside back piece is different from the front piece. It has this flap that's designed to add some friction to the system. Oddly, when I first worked on this, I used ball bearings on the axle to try to make things spin easily, and didn't have this drag flap that was in the original Gunpla version. And the filament actually spun way too freely, and inertia would unspool the filament. So I started adding friction back in, got rid of the ball bearings, added this flap back, though in a reduced format, to the back piece to engage with the filament spool rim. And I think the amount of friction now is pretty good. Sometimes I think it could add a little more friction, be fine, but I think it's okay. Again, this fits in a similar way to the front piece. 8mm M3 screws. Tighten them down, make sure the piece is fully engaged in the grooves. And put in the second screw on the back. Move the painter's tape and the back piece is done. Getting close now. You need to fasten a third magnet on the spool holder. Again, done a similar way with super glue. And again, the magnetic field of the magnets, they're already there. I'm going to try to push this third one around, so you need to make sure that it's set up before you stop holding it in place, or it'll move around. And of course, make sure the polarity is the same as the 2 magnets that are there. We're ready to put a spool of filament in our Drybox. One of the disadvantages with a spool holder that is in the center of the spool is that the hole in the spools is not a standard size. So each spool can have a different size, and you'll need a different size spool holder for that spool. The spool holders have a angle on the circular part that engages with the spool that does allow them to fit a range of diameters, but obviously it's only a limit, so at a certain point you need a different size, so you'll have to print out a spool holder of the appropriate size. The build includes different sized holders that should be appropriate for most spools. So you have to keep track of which side of the spool should go on the side with the magnetic pieces and which go on the side that the axle inserts on, because you want the magnets opposite this side, and obviously the spool needs to unwind so that the filament comes out from the bottom towards the front of the container. So you tighten that down, the axle, and check that everything seems to be running true, and push the filament out the exit. And then we are ready to prepare the cap for it. Add some desiccant to the desiccant bin. Put the lid on the bin and then insert it into its proper place. And then close up the box. And just to demonstrate how the magnetic retractor works, this retractor with the handle just sticks outside, fastens to those inside magnets, and then you can use it to spin the spool from the outside without ever letting air into the container. So this spool retractor is obviously another printed part. You'll have to print that out. It actually takes 6 of those same round magnets. They get glued in. There's a stack of 2 in each spot. The TPU part goes over the filament when it's not in use to seal up the dry box. Sometimes you'll need to drill that hole out with a 2mm drill to make the filament fit more easily in there. Retract the filament a little bit to put the cap onto the dry box, and you have one finished dry box container with filament. The filament dry box has 4 holes on each side for side mounting, and of course has the back mount. I hope the dry box works as well for you as it does for me, and thank you for watching.